Today we're going to be working on density. Make sure you have your density notes, your vocabulary notes out, and that you're ready to go. The specific vocabulary that we're covering today is mass, volume, displacement, density, relative density, and the density formula. Let's begin with mass. If you remember in our lab, we talked about mass being the amount of matter that's in a substance. So it's actually measuring how much matter is all put together to make an object. We measure that using a triple balance or a scale. And as you remember, we measure that in grams. Take a moment to fill in the word mass and the definition. Mass measures how much matter is present in a substance or an object. Here are several of the examples of the tools that we use to measure mass in grams. The first example is a digital scale. The second is a nice example of a balance. We talked about a triple balance. And the third is just a different kind of scale. It is not digital. The next vocabulary word that we're going to review is volume. As you remember, it's the amount of space that matter occupies or the object occupies. All that matter put together makes its mass, but that mass occupies a space in our world, and that's called volume. And you can see in this example, they're measuring the volume using a graduated cylinder. Take a moment to write volume and the definition of volume on your vocabulary sheet. You can see here a scientist is using a graduated cylinder to measure the volume of a liquid. As they look closely, they measure at the bottom of the meniscus. That's that small curve, because remember, gravity is pulling up the edges of the water. So when you read right in the middle at the meniscus, you see that it is 51 milliliters. And I know that it's in milliliters because I see an ml on the graduated cylinder. Our next vocabulary word is displacement. It's the procedure used to measure the volume of a solid or irregular shaped object by placing it in a known amount of liquid. If you remember, during Metric Mania, we tried to measure the volume of marbles. We started with a given amount of water. We recorded that volume. We added the marbles and we watched the level of the liquid rise because the addition of the marbles, which have their own volume. The difference between the two was the volume of the marbles. Take a moment to write down the word displacement and the definition for displacement. You can also color the water on your pictures if you'd like to. You can see in this example, a scientist was trying to measure the volume of a hammer. He or she couldn't find the volume of the hammer using traditional method because length, width, and height of a hammer is very difficult to do. It is an irregular shaped object. So the scientist had to use water displacement. Looking at the first graduated cylinder, you can see that there is 65 milliliters of water to begin with. In the second graduated cylinder, we have added the volume of the hammer. The additional volume made the water rise from 65 to 69. We can conclude that the difference between the 65 and the 69 is the volume of the hammer, making the volume of the hammer 4 milliliters or 4 cubic centimeters. Our next vocabulary word is density. That's a new vocabulary word for this week. It's how closely packed together the particles in an object are. We've talked about mass. That's the amount of matter in an object. And we've talked about volume, the amount of space that object takes up. Density is the combination of those two, or the ratio of those two. It's how much mass per amount of volume. So how densely packed all those little pieces are. Are they put together really, really tightly? Or is it held together really, really loosely? And we'll see some better examples of that as we move along. But density is really how closely together all the particles are packed in any given object. Take some time to write down the word density and the vocabulary definition. This slide gives you some great examples of density. You can see that brick is high bulk density. There's a lot of matter packed together tightly. There's low pore space. There's not a lot of little holes in that. The sponge has low bulk density. There's a lot of space in between. A lot of air can get in and out. There's not a lot of matter packed into a little space. In the upper right, you'll see a really good example of low, medium, and high density. You can see the high density has a lot of matter packed into the same space. Then the low density has only a teeny bit of matter packed into the same space. Density is going to determine whether an object sinks or floats. Something with a very, very high density is going to sink quickly to the bottom. Something with a very, very low density is going to rise to the top. Relative density is how the density of one object relates or compares to the density of water. Definition is the comparison of the density of one material as it relates to another, usually water. We'll find out that water has a density of 1.0. So if something sinks, it has a density greater than 1. If it floats, it has a density less than 1. Relative density, again, is how it compares or relates to water. Take a moment to record relative density and the definition. You can also record the density of water as being 1.0. You can see in our example, relative density, we're comparing the density of those three objects to the density of water. The yellow object in A, density compares almost the same to water. So we would expect it to have a density of almost 1, maybe 1.1. B, we can see sunk halfway. So if we compare it to water, the density is going to be higher than 1.0 because it is sinking. C, on the other hand, is going to have a higher density, 3, 4, 5, 6, higher because it's sunk to the bottom. Its relative density to water is higher. Our density formula is density equals mass divided by volume. Another way to say it is the ratio of mass to volume. How much mass is taking up that space? Like we saw before, in the low density, there were only 3 little dots taking up that square. And in the high density, there were many dots taking up that same space. So density, again, is mass divided by volume. Take a moment to write down density formula and the definition of the density formula. Here again is our density formula. Density is mass over volume, remembering that mass will be grams, and we will determine a mass of an item using a balance or a scale. And the volume is either going to be in milliliters, liters, kiloliters, or cubic centimeters, depending on the way that we find the volume of the item or whether it's a liquid or a solid. The sources for this information came from many different places. If you'd like to visit some of those sources to learn more, feel free. At this point, you should be finished with writing down all your vocabulary words, finish writing down all the definitions, and you can take some time to color some of your pictures if you would like.